Greetings, Earthlings! How many times have you looked into the amazing night sky and pondered how many things you can't see? Astronomers wonder about this all the time and are always trying to push the limits of what we can't see. I created this little introduction to tell you about something you may not even know exists. I would like to discuss a special type of star. This star is called a neutron star and ordinarily can't be observed without highly specialized equipment. First, I will be discussing what a neutron star is and how they are created. Then I will be discussing a special type of neutron star and briefly cover the applications it may have for the future of science. Neutron stars are really a phase in the life of a normal star. According to currently accepted theories, if a star has sufficient mass, at some point the gravity produced by the star is too powerful for the material of the star to withstand. The star begins to collapse, imploding and causing massive amounts of heat and energy to be released. This then causes a shock wave powerful enough to expel much of the outer mass of the star into space. This is called the supernova phase. If conditions are correct, the remaining mass at the center of the supernova will be the neutron star. Neutron stars are extremely dense. Due to the extreme compression from gravity, scientists estimate the density is so high that a single teaspoon of the material has a mass equal to that of 900 times the Great Pyramid of Giza. Neutron stars typically have very strong magnetic fields. They also rotate very rapidly. This rotation is due to the original star's rotation and is much faster than the original rotation due to the conservation of angular momentum. Unlike Earth, the rotational axes and the magnetic axes are not always aligned in neutron stars. Most commonly, the only detectable light that a neutron star emits is in the radio wave frequency. This light is emitted mostly from the magnetic poles, as shown in this impression of a neutron star. Some neutron stars do emit visible light, though. There is a specific type of neutron star called a pulsar. This type occurs when the rotational axis is not aligned with the magnetic axes and the star acts like a lighthouse as it rotates. Pulsars have several applications in science. It turns out that the rotation is very stable and consistent for some pulsars. These could be used as pulsar clocks to establish a precise time standard. Pulsars could be used to create maps of relative locations in the universe because a pulsar can be identified by its frequency. Also, scientists are using an array of known pulsars to detect anomalies in space-time like gravitational waves by measuring variations in their frequencies. The discovery of the pulsar is what led to the first known observation of neutron stars. Since the first pulsar was discovered, many more have been found. Scientists hope to use the very specific properties of pulsars and neutron stars to advance the sciences, including the study of materials, quantum mechanics, and space-time. I encourage you to do your own research as there's much to learn. Thanks for listening, and remember to look up next time you're out at night.